So, section 2 will be introducing logarithms, which most of you probably have never done before and don't know anything about. For today, we're just going to focus on introducing how to solve them, how to do some different things with them. It's basically an exponent is what a logarithm is. We're going to spend some time writing them in logarithmic form, exponential form, and teaching you how to solve and simplify some of them. So for right now, that's kind of what you need to know. It is an exponent. It's another way to write an exponent. Flip over to page 510. We'll just start working through some examples. Just an example of what one looks like up there now. That is red, log base b of x equals 3. Log base b of x equals 3. And they could be any letters, any numbers, but that's how they're read no matter what. You could have log base 2 of 4 equals 6. That's not a correct logarithm, but that's just another one example of how you read log base 2 of 4 equals 6. So that is in logarithmic form. Obviously, if you see a log in there, then you should know that's in logarithmic form. Exponential form will not have that. So if we look at example 1 there, it says write each in exponential form. So we're starting off with 2 of those. Log base b of 8, or log base 8 of 1 equals 0. And we are to write that in exponential form. So you take the base, the 8, that's your base number. This is your exponent, equals 1. So you just change that to 8 to the 0 power equals 1. 8 to the 0 power equals 1. So that's how you're going to do all of those problems. Your base is still going to be the same. It's log base b, and this is base 8. So you know that's the way to keep that straight. So it's this number to this number equals that. Question? We'll get there. Right now, just focus on converting. So log base 2 of 1 over 16 equals negative 4. So what would your base be for this one? 2 to the what? Negative 4th equals 1 over 16. And yes, that is true. 2 to the negative 4th is 1 over 16. So then example 2, you're given the exponential form and you're going to change it into a logarithm. So you have 10 to the 3rd power equals 1,000. So obviously, if you're writing that in logarithmic form, you're going to write log out front. So log, and what's your base? 10 still. Log base 10 of what? 1,000 equals 3. So again, these first problems are not really any solving, you're just writing it a different way. Log base 10 of 1,000 equals 3. And your next one, 9 to the 1/2 equals 3. So we write log, what's your base? Log base 9 of 3 equals 1. So moving on to example 3, now we will use the ability to switch those back and forth to solve. Log base 2 of 64. So now they don't give us what that equals to. That's what we have to figure out. Log base 2 of 64. So you could set that equal to x. That's what we're looking for. What is log base 2 of 64? And then you can write that in exponential form. So what would your base be? 2 to the, careful, 2 to the what? X equals 64. And then you just have to figure that out. 2 to the what power gives you 64. Now, the way the book writes it, and it's fine, because it kind of goes off what we had, what we were doing last time. Our bases are not equal here, right? So we need to get them equal. So we can write that as 2 to the x equals 2 to the 6th. And now your bases are the same. So using section 1, you can set your exponents equal. And there's nothing to solve there. It's x equals 6. Later there will be. Right now, they're not. Log base 3 of 81. And again, we can set that equal to x. That's what we're looking for. 3 to the what? X equals 81. 3 to the what is 81? 4. So we could write that 3 to the 4. So we get x equals 4. Questions on those? Flip over to 512. We'll do some more where it's actually given to you as an equation. These first two problems, they were just giving you this. They didn't have an equal sign. That was an expression. We put the equal sign in there, and so we pretty much made it an equation anyway, and that's what example 4 is. Not a whole lot there. So it says solve log base 4 of n equals 5/2. Only difference here is the variable's in a different spot. You're still going to write it in exponential form. What's your base? So we have 4. What's your exponent? So the 5/2 equals n. And I would type that in your calculator. 4 to the 5/2. Make sure you use parentheses. What? 32. So we have 32 equals n. Log base 9 of x equals 3/2. So we change that to 9 to the 3/2 equals x. Now just to show you what the book's trying to get you to do here, if you didn't have a calculator, what could you change 9 to with a base? 3 to the what? 3 to the 2nd, and then you could raise that to the 3/2 power. And what do you do when you raise this power to the power? So what's going to happen? The 2's cancel, so you end up with 3 to the 3rd, which is so most of you, I don't know if any of you can do 9 to the 3/2, but if you set it up that way, you got to the answer without using a calculator. So keep that. Do one more. Log base 16 of x equals 5/2. So what's your base? 16 to the 5/2. So what do we get there? $1,024. One last example on page 513. We'll do example 6 there. Looks a little more drawn out. We have log base 5 of x squared minus 2 equals log base 5 of x. So when we were doing exponential functions or equations last time, we actually have an example up here. Right here. When those bases are the same, what can you do with the exponents? You set them equal. You can use that, you can apply that same principle to this. We have log base 5, log base 5. So your logs are the same. So you can set these two parts equal to each other. So x squared minus 2 x. We just got to solve for x. What do we need to do? What? You could do that if you didn't have that other x in there. Move the x over by, huh? So we would have x squared minus x minus 2 equals 0. And you need your zeros here. Question. We want the zeros. 2 and negative 1. And we present the possibility of extraneous roots again here. So we need to plug our answers back in. Make sure they check out. So if we put 2 in to the original, you've already found out it works. 2 squared minus 2 equals log base 5 of 2. So it does check out. 4 minus 2 is 2. And log base 5 is 2. Those do work. The other one work? Did you square the negative 1 correctly? Positive 1. So we'd have 1 minus 2, log base 5 of negative 1 equals log base 5 of negative 1. What's your book say down there? So since log base 5 of negative 1 is undefined, negative 1 is an extraneous solution. You can't have this number being a negative. So that one is. X equals negative 1 does not work. Choose your own solution. Questions before homework? Pages 514 through 516. We will do 1 through 12. 19 and 20. 23 through 49. 56 and 57.